Okay, so let's do question C. So again, I just inserted the question down here so I can see it better. Again, this is our cosine law on the right. Start with a diagram of a triangle. Label the sides. We have sides LMN, LMN, which means we're going to have lowercase n here, lowercase m, and lowercase l. Again, we're given all the sides, we're missing all of the angles. So side M is 4.6, side N is 3.3, and L is 5.5. Okay, all this is in centimeters. And we need to round to 1 decimal place. So in this case, we're missing the angles, which means if you use your cosine law, you can use sine law in this case, because for sine law, again, you have to have at least one angle and opposite side to it. So we can't use that. We have to use cosine law. Let's say we want to find angle L, right? So I'm going to write my cosine law for this. I'm going to say side lowercase l squared equal to n squared plus m squared minus 2n times m times the cosine of uppercase L. Right, so that's going to be that angle right there. So I'm looking for the angle L. I'm going to do a little bit of algebra. I'm going to move the n squared and m squared to the left, and then I'll plug in numbers. So I'm going to do this. I'm going to do L squared minus n squared minus m squared equal negative 2n m cos L. Let's divide both sides by negative 2nm. Negative 2nm. So they'll go away from the left side. So from the right side goes to the left side. Negative 2nm. Now we have cos L by itself. So at this point, you can start plugging numbers to make your math a little simpler. So L is given. It's 5.5 squared minus n, so 3.3 squared, minus m, so minus 4.6 squared here, over minus 2 times n, which is 3.3, times m, which is 4.6. Okay, and all this equals to cosine of angle L. So once you calculate all this stuff on the left side, we can take the inverse of that to get the L by itself. So let's see what this equals to. So 5.5 squared minus 3.3 squared minus 4.6 squared, that equals to negative 1.8 over, so you're going to do divide on the calculator, open bracket, and then you're going to say negative 2 times 3.3 times 4.6. Now this is going to give you the answer for the whole thing. So let me think. Let me just skip a step here and then I'll come back to it. So all this is going to equal to 0.059288, so on. And all this equals to cos L. Okay, so then the L is going to equal to the inverse of this. So L is going to equal to cos inverse of all of this. 0.059288. And because I already have it in the calculator, I don't want to get rid of it. So this will equal to 86.6 degrees. So that's going to be your angle L. So let me just finish here. So this would be cos of L, and negative 2 times 3.3 times 4.6 is negative 30.36. Okay, so now you have the full flow of the calculations, but again, I don't recommend that you do each step separately because they will lead to rounding errors. You want to do everything on the calculator in one go. Okay, so you calculate the numerator, you divide it by the denominator, you take the inverse of cosine to get your angle. So as you can see, we found our angle L. So now we know that this is 86.6. Now, once you know one of the angles and you know all of the sides, it's easier to use sine law to find the missing angles, because sine law, you just need to, let's say if you want to find side or angle n, let's say, you're going to write sine n over side n equal to, we know sine of L now, so you're going to write sine L over side L, right? So with sine law, it's simpler because we just need to move this lowercase n to the top. So we get sine uppercase n equal to n times sine of uppercase L over lowercase l. Plug in the numbers. So in this case, n is 3.3. Sine of 86.6. And L is 5.5. So it's a lot quicker than to use cosine law. So we get 3.3 times sine 86.6 divided by 5.5. That's going to be 0.5989. So that's again the sine of angle n. It's not the angle n itself. 0.59894 and so on. So again, that's still not the angle. So the angle n is going to be this inverse of this number. So sine inverse is 36.8. Okay? So now that you know the angle n, we can find the last one by just subtracting. If you wanted to use cosine law to find angle n, you would have to go through all these steps. Like, for example, here we found angle E, right? We went through all these steps here, which is quite a bit of work, right? We have 1, 2, 3, 4, 5, 6, 7, 8, 9 steps we had to do. Whereas sine law, 1, 2, 3, 4 steps. And again, you do all this in the calculator in one go. There's no extra steps you have to do. So sine law is a lot faster whenever you have the required information. But sometimes you don't have a choice. Sometimes you have to use cosine law. So once you know two of the angles, the third one, of course, you can just do 180 minus the two known angles. So now we know these two, right? We found n, and we know L. So to find the last one, M, we're just going to do M equal 180 minus the two that we found, 86.6 minus 36.8. So 180 minus 86.6 minus 36.8, we get 56.6. So that's going to be our M angle right there. Okay? So it's really a combination of sine and cosine law. You could do all the steps you just using cosine law, but it's just going to be a bit more work. So the last question was question 13. Question 13, we have two drivers leave their school at the same time and travel straight roads that diverge by 70 degrees. One driver travels at the average speed of 33.0 kilometers an hour. The other driver travels at 45 kilometers an hour. How far apart will the two drivers be after 45 minutes to the nearest tenth of a kilometer? So here, because we have different units, we have kilometers per hour and we have minutes, you have two choices. You either convert your speeds to have kilometers per minute, or you convert your time to hours and then use that to find the distance. Because we're looking for the distance, we need to remember some of the sines 10 or sines 9 even to do this question. So remember, your speed is defined as distance over time, right? Now we're interested in the distance, so we're going to rearrange this. So distance equals time times speed. So this is going to be time times the speed. Okay? So, or you might have remembered D equals T times S or S times T. So we need to use this equation to find the distances, how far they've traveled from the origin, from here, until they travel for 45 minutes. So the next step is to convert 45 minutes to hours. 45 minutes is 3/4 of an hour, okay? Because each quarter is 15 minutes. Or what you can do is do the long way, 45 minutes. We know there are 60 minutes in an hour, so we can use dimension analysis, which means we can do minutes on the bottom, hours on the top. There's 60 minutes in 1 hour, so basically end up with 45 hours, 60, which is simplified, so end up this. So minutes and minutes will go away, and you end up with hours on the top. So 45 times 1 is 45 over 60, and this simplifies to 0.75 hours, so 3/4. So that's how far, for how long they traveled. They traveled for 45 minutes or 3/4 of an hour or 0.75 hours. So you're going to use that in this is our time, in our equation for distance. We know their speed for each of the cars, okay? So let's say, doesn't really matter which one is which. Let's say the red one was going at, let's call this red, and this one's going to be yellow. Okay, so the red car traveled for, again, 0.75 hours. So the distance for the red car is going to be, the time is 0.75 hours times the speed. So the red is 33.0 kilometers per hour, right? So notice here the hours and the hours will cancel out, and you're left with just the kilometers, which is the distance. So 0.75 times 33 is going to be 24.75 kilometers. So that's going to be this distance right here, 24.75 kilometers. So that's the distance that the red one, not the yellow. This is going to be the red car, 24.75. So the yellow car the distance is going to be 0.75 hours times the speed, which was 45 kilometers an hour. Again, hours and hours will reduce away. You're left with 0.75 times 45, which is going to be 33.75 kilometers. So that's going to be the yellow car. So this is 33.75. Okay, so now we know two sides, we know the angle. The question is, how far apart are they? So that's the question mark. We're missing the third side. Now, you could try using sine law, but again, using sine law, you need to know at least one of the other angles, which we don't have. So we have no choice. We have to use cosine law. So let's just resketch this diagram down here, or here, and label everything that we know, and maybe pick some letters, so it's easier to use the cosine law. So we know that this angle here is 70, okay? Let's call this angle A. So this is going to be side A. That's the side we need to find. So this is A, this is going to be B, and this is going to be C. So B and C are unknown, but we know that this is going to be lowercase c and this is lowercase b, which we do know. We just found them. So side C is going to be 24.75 kilometers, and B is going to be 33.75. So the next step is to use cosine law, and in this case, we're looking for side A, so you're going to write a squared equal to c squared plus b squared minus 2cb cos of angle A, which is given to be 70 degrees. So to find A, we need to plug in numbers and then square root the answer. So A is going to equal to the square root of c squared, which is 24.75, plus b squared, which is 33.75. So don't forget to square it, minus 2 times c, which again is 24.75, times 33.75, times the cosine A. Cosine A is 70, or the angle A is 70. Take the square root of all of this, and you'll get your value for the side A, and that's going to be the distance apart between the two cars after 45 minutes of driving. So again, do each step carefully here. Don't forget to square anything, and make sure you have your calculator set to degrees. So 24.75 squared plus 33.75 squared minus 2 times 24.75 times 33.75 times the cosine of 70, all this equals to 1180.2375. And then I'm going to take the square root of this number. So 1180.2375 and so on. Okay, so again, I wouldn't erase the answer, just take the square root, and we get 34.35 kilometers, which means that the two cars are going to be at this distance apart after 45 minutes of driving. So this question has quite a few steps involved here, but it's really about knowing some of the signs that you should know from like previous grades. Now you can change this to meters if you want, but in this case we can just leave it in kilometers. So it's asking us to round to the nearest tenth. So nearest tenth, that would be 34.4. Okay, so that's going to be our final answer here.